Hello, good morning all. Am I audible? Okay, screen is visible.
Yes, sir.
Okay. In the previous class, I have already started a third module, that is artificial neural network. Okay, like second module, decision tree learning. This is also one type of learning, and this is artificial neural network learning. It means that here we are going to construct artificial neural network. Okay, and I already shown you how exactly these artificial neural network look like. Okay, so there are some layers are there. The first layer is input layer, and last layer is output layer. In between these input and output layers, there are some hidden layers are there. Okay, so these general idea already I have given to you, and with one real time project or with real time problem in the previous class, I explained this artificial neural network representation also. So the first topic of this module was introduction, then the second topic was artificial neural network representation. Okay, so that representation, how we can use in our real time project or problem, I have explained you. Once again, briefly I revise it and then I go to next topic today. Say in this slide, in the first the above diagram, whatever I am marking here, this is actual our setup of our system in our autonomous car. Okay, so our intention is to drive a autonomous car, right? So here steering is there, and here camera is also there, and here one laptop is also there. So this is the setup of our system, and this camera itself is providing a input to our artificial neural network. Okay, this is just a general and external view of our system, but internally, technically how this system works, we will see here in the below diagram here in left side. So this is a small box is there. Now this is what actually we got the input from our camera. Okay, this camera is giving us some around 960 pixels, and these 960 pixels are arranged in such a way that 30 rows and 32 columns, so it is called as 30 by 32 grid of pixel. Okay, so this camera is continuously, however the car is moving in which speed, so that is normal speed, that is 112 kilometer per hour speed. Okay, so in this normal speed, however the car is moving, at the same time camera is also continuously giving us the input in the form of these 960 pixels, that is nothing but 30 into 32 grid pixel. So these 960 all are called as inputs only. So okay, these 960 are called as inputs, so you can consider it as a input layer of your artificial neural network, and these inputs are feeding, or they are given to next layer as a input, that is a hidden layer. And in this hidden layer there are only four units are there, and these four units are taking these all 960 inputs, and they are also producing some outputs, and those outputs will be input to the next layer, that is called as output layer. And here output layer contains some 30 units. Okay, 30 units, and it is not compulsory, and it is not mandatory that we should take only four hidden units and 30 output units in every problem. It depends on problem to problem, it varies from problem to problem. Okay, so here we are considering the four hidden units and 30 output units. Okay, so here these whatever hidden layer is there, no hidden unit, this hidden layer is completely zoomed in, and here once again we have drawn it as in the form of a matrix or a table. And what is this matrix actually? In this hidden layer, in these hidden units, so some weights are there. So these hidden units are giving us some weights. Okay, so this matrix is called as a weight matrix, or it is a matrix of weights, and I will tell you later what are these weights and all those things. Don't worry, just remember that word weights. And these weights matrix contains some black color weights and some white color boxes or weights there. Okay, these white boxes or white blocks, whatever you are observing in this diagram. So these all are called as positive weights. Okay, remember the white color boxes are blocks are indicating positive weights, and black blocks are indicating negative weights. Okay, so white blocks are indicating positive weights, and black blocks are indicating negative weights. And here so these all are represented as a hidden layer or hidden units which are giving us some weights. And in this problem, in this artificial neural network, this is the main task, this is the main challenging task for us, because we have to find out these weights. Okay, so hidden layer gives us some weights, and in hidden layer only we will find out the weights, and how to find out these weights I will explain you in the next topic. Okay, so then again we are comparing this output layer with only one small rectangle with again some blocks, some small number of blocks, so which is written here. Okay, so this is actually represented as output layer, and here since there are 30 output units are there, so this is represented in the form of 30 units. Okay, 30 output units. So here this is input layer, this is the hidden layer, and this is the output layer. So this is the representation of artificial neural network. And these, since I am calling these all 30 units as output units, these units itself, they are telling us, or they are telling to the system, or they are telling to the car whether you have to rotate the steering towards the right side or left side, or only little bit right side, and if it is right side, how much amount of degree I have to rotate the steering towards right or right left, or whether I have to keep the steering straight only. So these all commands, steering commands, will be given by these output units only. So if it is a sharp curve towards the left, then it tells you to take a sharp left. If it is a sharp curve towards the right side, then it tells you or that system to take the sharp right side. It means we have to rotate completely our steering. So like this, steering commands are divided into 30 units here. It means 30 degrees, total 30 degrees. Okay, so this is a representation of our artificial neural network for autonomous car or autonomous vehicle project. Okay, see, let us go to next topic today, that is the suitable problems what we can solve with this technology, that is our artificial neural network. So what kind of problems we can solve here, the appropriate or suitable problems, so where we can apply this neural network are listed here. Just have some concentration, attention. It is very easy to understand what type of problems there should be. If those problems have these features or characteristics, then directly we can apply these neural networks to our problems. Okay, see, this artificial neural network is well suited to the problems, or well suitable for some problems in which these training data is nothing but what, training examples. Training data is nothing but training examples. They are corresponding to some noise. It means that our problems, if they have some noise, okay, if they have some noise or some errors, and they are also related or dealing with some sensor data, so like our camera in our autonomous car, right? So sensor data, if you are using such type of data, and if that data has some errors and some noise, so then we can use this neural network. Okay, artificial neural networks. So examples for this sensor data are just like I just now I told you. So cameras and microphones, our mic, whatever we use, this type of data, if you are dealing with in your problem, then you can use this neural network. Okay, so then it is also applicable to some other kind of problems where we are using some representations which are using more number of symbols. For example, in just previous module only, we represented our hypothesis in the form of a symbol or in the form of a decision tree, if you remember. In first module, we have also studied hypothesis, but we have represented in the form of some angle brackets, and inside that angle brackets we have written some constraints like a specific value of attribute, and sometimes we have used some question mark, sometimes we have used some null symbol. Okay, so that is just like it is a mathematical notation it is, but if we are representing our hypothesis with the help of more and more symbolic representations, like our decision tree, for such kind of problems also we can use or we can apply this artificial neural network. And in these cases like artificial neural network, what we are studying in this module and in this decision tree learning, what we have already studied in this previous module. Okay, in these both cases, artificial neural network as well as decision tree learning, these are going to give us the result, so which are comparable accuracy, which are the accuracy can be comparable. It means that so whatever the output is given by artificial neural network and whatever the output given by decision tree learning, so both the outputs we can compare them, because almost the outputs from these two methods can be almost the same. Okay, so we can compare them. So there is no there is a there is not a long gap, or there is not a long difference between the outputs of artificial neural network and the decision tree learning. So both the outputs will be almost equal approximately. Okay, so here whatever the accuracies are given by this decision tree, what is the main purpose of this decision tree? So obviously they have to classify our training examples as positive or negative. So accuracy, how correctly that decision tree is classifying our training example. So the similarly artificial neural network is also classifying the training examples. So the both the outputs or both the methods are giving some outputs. No, the accuracy of this both the decision tree as well as artificial neural network methods are comparable. It means that both of all outputs are almost same. Okay, so here in this module we are going to study one very very important algorithm that is called as back propagation algorithm. In previous module, how we have studied ID3 algorithm and the C4.5 algorithm, which is an extension of ID3 algorithm. So what was the purpose of ID3 algorithm? The purpose of ID3 algorithm was to construct a decision tree, right? So similarly here also in this module we are going to study artificial neural network. It means that we are going to construct artificial neural network. Just now I told you how exactly it looks like. It means that we are going to write some units for input layer, and we have to write some units for hidden layer, and we have to write some units for output layer. So these round, small circles, whatever I had shown in that previous diagram, so those are called as units of particular layer. It may be input layer, it may be hidden layer, it may be output layer, right? So here also we are going to construct some network. Which network? Neural network. And particularly it is not a biological network, it is an artificial neural network. So in this module we are going to learn artificial neural network. Okay. So to learn these artificial neural network, we are going to use one very, very important algorithm that is called as back propagation algorithm. And why they name it as a back propagation? So I will tell you in next topic when I discuss this back propagation algorithm. Okay, this is a most commonly used artificial neural network technique. So what is this back propagation algorithm? It is the most commonly used algorithm, most commonly used artificial neural network learning technique. Okay, so this is most common algorithm for artificial neural network. Whenever artificial neural network concept or topic comes in your mind, this algorithm should comes in your mind. That is back propagation algorithm. Okay, so it is suitable or it is appropriated for some problems, so which have some characteristics, which have some features. What type of problems, for which types of problems or what type of problems this back propagation algorithm or artificial neural network is suitable? Let us see here. Some 5 to 6 categories are there, 5 to 6 characteristics are there for these problems. The first category is the instances are represented by many attribute value pairs. See, since from first module itself, we are seeing these attributes and attribute values. Okay, so in second module also we have seen some attribute and attribute values. The problems which are having some instances or some examples, so those examples are represented, or those examples have some attribute and attribute value pairs. For such type of problems, these artificial neural network as well as this back propagation algorithm is suitable. Okay, see here the target function, what we have to calculate or what we have to learn is defined over these instances. So target function already I told you, target function, target concept, none other than same, right? So target function, what we want to find out. Okay, so that target function is defined over these instances or these examples, many examples. Okay, so that instances are described, or that the target function, sorry, the target function is represented in the form of a vector. Okay, in the form of vector, and vector of what? Vector of some features. So here in our example, the pixel values in our example, one system we have used, in our autonomous system, alvin system. In our example alvin system, the values, pixel values are examples for these instances, so which are represented in the form of vector. Okay, so here these input attributes may be highly dependent or they may be independent. Just remember these two words, correlated or non-related. So these input attributes, whatever the pixels we are giving no as the input to our problem, these inputs may be sometimes dependent or sometimes independent. It means that one value of a pixel is dependent on its previous pixel, or some value is not dependent on other pixel values, like this. Okay, so it means any input attributes what we are giving to our artificial neural network as an input. So these input values are dependent as well as independent. It's based on our nature of our problem. Okay, so and these input values will be any real values like our just camera input, that is pixels. Okay, so that the camera is continuously capturing the highway or road image of or video of highway or road, and that is nothing but our real values. Okay, so for such kind of problems which are dealing with these real values, we can use this back propagation algorithm and artificial neural network. And second type of or second category of problems where we can use them is where this target function output, that is the output of this target function may be three types of values. So what are those? It may be discrete value, the output may be discrete value. Okay, discrete value means, for example, if you consider temperature as an attribute, attribute values are discrete values. When it is discrete, if it contains only three or four possible attribute values like hot, cool, and mild. Okay, these are discrete valued attributes. So what continuous attributes means, temperature may be 30 degree, 32 degree, 35 degree, 40 degree, like this continuous values, whatever we can consider for a temperature, then they are called as continuous. Okay, so similarly here, some attributes may be or some outputs may be real valued also. Real valued like just now in previous point only I discussed what about this real values. So outputs also may be real valued. So obviously in our example output is a real valued only, because output is nothing but here the direction of a steering or a steering command also we can call it. The command steering or command of a steering or steering command. So how much amount of degree I have to rotate the steering. So that is a real valued output, right? And similarly, if the output may be a vector of some real as well as discrete valued attributes. The problems which are containing some target function, and that target function is giving us some output which is in the form of discrete valued output, or it may be real valued output, or it may be combination of both of them. It may be both discrete valued as well as real valued. For such type of problems, we can use these artificial neural network and the back propagation algorithm. So because of that only here output we are getting in our algorithm system, which is autonomous car or vehicle problem, we are getting the output in the form of vector of 30 attributes, just now I told you, right? So it is a vector of 30 attributes. So because of that only it is recommended to use these 30 attributes as a steering steering directions. So it means that there are 30 positions are there. The 30 possible positions are there for that steering. Okay, if you rotate, if you just assume that the steering position is completely left side. Okay, so the next point will be a little bit right side. Okay, and the next point will be again a little bit right side. Like this, there are 30 brakes are there from left to right. Okay, so 30 these steering commands are divided into 30 directions. Okay, the value of each output is some real number. See here, is that a real number? The output will be the real number, and that real number will be value will be in between 0 and 1. It means 0 0.1, 0 0.2, 0 0.4, 0.5, and so on till 0.9 and 1. Okay, the output will be a real number which lies between 0 and 1. Okay, so which in this case it is corresponds to what is the this output is means what it is. Already I told you it is a steering direction. Okay, so but this actual value, this real number, what it is indicating? It is indicating the level of confidence. So suppose your road is bending towards the right side. Okay, obviously you will rotate your steering towards right side only. So because you have that much confidence that, and you have knowledge that I have to rotate in a right side only. So this much confidence that machine also should get. So that level of confidence will be represented by this real number which is in between 0 and 1. Okay, this confidence level itself is the real number which is in between 0 and 1, which is corresponding to our steering direction, right? So right. So after this, the third problem is the training examples may contain some errors. See, so just now I told you one word noise, right? So if suppose if our training examples or training instances contains some errors or noise, so on such type of problems also we can use this artificial neural network. Okay, and these artificial neural networks are very very strong for such type of problems because they can easily handle such type of problems. Because of that only we told that artificial neural network is a robust or it is a strong for the problems which contain some noise or error in our training data or training example. Then fourth type of category of problems are long training times are acceptable. See, the training times may be small and training times may be more. So because in only one day nobody can learn any new thing. So it takes some sweet time, its own time to learn any new things. Similarly, the problems which are taking so much amount of time, a lot of time to be learned. Okay, so for example, if you consider our Alvin problem only, Alvin system only, so for the first time in only one day it has not learned to drive a car, right? So it has taken its own time to learn it. So the problems which are taking a lot of time to get trained, so such type of problem also can be solved with artificial neural network. Okay, see, then the problems which are taking a less amount of time for evaluation. Okay, see, fast evaluation of learned target function will be required. The problems which have a fast evaluation technologies. So already you have find out or you have determined the target function. Okay, no problem. So to find out this target function, you have already taken lot of time. Okay, to get trained. So now to evaluate whether it is correct or not. So to evaluate whether it is properly classifying that training example or not. So this evaluation time is there, no? That evaluation time should be very very less. So if it is very very less means what it is? It is a fast evaluation. Fast evaluation. So here the evaluation time should be very very less. Such type of problems are suitable for this artificial neural network. Okay. Then because this Alvin, whatever is there, Alvin system, it is applying our neural network, artificial neural network, to so many number of times per second. You just imagine how much speed that car is moving. So because for every second the car is continuously moving, I already told it is moving in the speed of 112 per hour. Okay, so 112 per hour means per second how much distance it travels and in which speed it is traveling, you only calculate, right? per second, every second that camera is continuously capturing the video of our highway or road. Okay, so this artificial neural network is applying many times per second to our system alvin. Okay, so because of that only, that evaluation step should be very quick. It should not take a lot of time. So only once that alvin has taken a lot of time to get trained, after that it should not take a lot of time for evaluation purpose. If it wants to take more time to train or to get trained or learn, now itself it can take 1 or 2 days extra. But once it has started to use, or once it has started to drive the car, at that time it should not take a lot of time for evaluation. Okay, so this is evaluation time should be very very small. Then last one more type of problem where humans no need to understand the learned target function. See, there are some target functions are there which are computed or determined by our machine like or system like Alvin. And these target functions, it is not necessary to understand by the human beings. If it is understood to this Alvin system, then it is enough. Okay, the weights. Okay, in the next topic I tell you what are these weights. Okay, where we get these weights, in the hidden layer we get the weights, right? So these weights which are given or learned by these neural networks are difficult for humans to understand. So these weights are difficult for human beings to understand. So who have given these weights? So we have got these weights from neural network. Okay, so these neural networks are giving some weights. So just now I have shown you then one matrix of weights in the form of white and black blocks. Okay, so here some positive weights may be there and some negative weights may be there, and these weights are difficult for human beings to understand. Okay, then communicating or explaining these neural networks to these humans human beings is more difficult than communicating learned rules to human beings. It means that so to explain or to describe these whatever the weights are there, no weights, it is very very difficult. So describing these learned neural networks for human beings is difficult than comparative to learned rules. So already I used this rules word in the previous module. If you remember, rules are nothing but the path from root node to leaf node in our decision tree, right? So we can explain or we can give this details to human beings and they also can understand it easily. But for human beings, it is difficult to understand these neural networks or the weights which are given by these neural networks. Okay, so for such type of problems, so where humans are not necessary to understand these target functions. So for such type of problems, six categories I explained you. So for such type of problems, we can apply the artificial neural network and the back propagation algorithm. So let us go to next topic, that is perceptron. Very very important topic for your exam point of view. See, just remember one thing in your mind. This perceptron is nothing that it is a one type of artificial neural network. That's all. Okay. So this perceptron is a type of artificial neural network which is most commonly used. So because of that only, so we can call this perceptron is nothing but artificial neural network only. Now onwards, wherever I use this perceptron word, you can just imagine that it is an artificial neural network. Okay, and this perceptron is just like the heart of our artificial neural network, which is a main part of our artificial neural network. Because of that only, so wherever I use this perceptron word, you can imagine it as an artificial neural network. So this perceptron is just like a main part of artificial neural network. It is just like a CPU of our computer system. Okay. So similarly, in artificial neural network, perceptron is playing a very very vital role or important role. Okay. So for your reference, once I want to show you how exactly this perceptron looks like. Okay. So if you observe this diagram carefully, you can see here it is very very close to our artificial neural network representation only, because artificial neural network contains three types of layers: input layer, output layer, hidden layer. And these layers contain some units, small small circles were there, right? So these are units are also present in this perceptron. You can observe here in this left side. So here some circles are there. So these are called as input units. Okay, and these input units are nothing but x1, x2, x3 up to xn. And along with this x1, x2, xn, there are some edges are there. No, those edges are having some labels as a w1, w2, wn. These ww are nothing but they are weights. Okay, weights which are corresponding to our input layer. So then these weights together along with these inputs in x1 to xn, they are multiplied and they have added. So these all sum of these all combination of input x1 to xn and w1 to wn weights. So these all things will be together and the sum will be given to the next layer as an input. The next layer itself is a hidden layer. Okay, so here you can observe here x0 is there. Okay, and its corresponding weight is there w0, and here x1 is there and its corresponding weight 1 is there, x2 is there and its corresponding weight is there w2. So like this xn is there and its corresponding or respective weight is there wn. So x1, x1, x2, these all are inputs, and w1, w2, w3, these all are weights. So these all together will get into the next layer as an input, which is a hidden layer. And here these all will be summed together. So these all called as here summation of wi into xi, wi into xi, or we can write it as xi into wi also. So where I value starts from 0 and it ends with a n. Okay, so these all multiplication of input values with weights will be given to next layer as a input. That is nothing but a hidden layer. So then in this hidden layer there will be some processing, and that process will be I will explain in the next topic. And this will be given as a output, that is O. Okay, this O is nothing but here output of this perceptron or output of this neural network. And what it is giving as output, if you observe carefully here, the multiplication of this W and Xi, the multiplication of this W and Xi and its summation, suppose if that value is greater than 0, then the output of this perceptron will be 1. If the multiplication of these weights and examples is less than 0, it means that the multiplication and the summation of these weights and inputs is in terms of negative values, then obviously that output will be in the form of -1. So the only two possible output values for every perceptron is +1, -1. So the +1 and -1 completely depends on our input and our inputs and the weights, associated weights. Okay, so if the multiplication of these both weights and inputs are greater than 0, it means that positive numbers, then if its perceptron's output will be +1. And if the product of these xi and wi is less than 0, then the output of this perceptron will be -1. Okay, so just keep this much in your mind. The same thing I am explaining once again here, that's all. Okay, the perceptron, how it exactly looks like, already I told you. So here perceptron is nothing but it is a heart of artificial neural network, or this is a main part of our artificial neural network, or else you can treat it as a neural network itself only. Okay, perceptron is nothing but artificial neural network itself. But since this artificial neural network is taking some inputs and it is producing some outputs, we will talk about these inputs and outputs in this slide. Okay, see, this perceptron takes a vector. Okay, takes a vector as an input. So what vector it is taking? It is taking a vector of real valued inputs as an input, right? So just now I told you in our autonomous car or vehicle problem, that is which one it is? Alvin system. In our Alvin system, if the perceptron was taking some real valued inputs, right, from that camera, So here it is that vector is that input is in the form of vector. Okay. Then what it calculates? It calculates one linear combination of these inputs. Linear combination of these inputs means what? Inputs just now I told you x1, x2, x3 up to xn, right? Then combination means what? Along with these inputs there are some weights are there. So because of that only we have used this word combination. X1 W1, X2 W2, X3 W3, X4 W4 like this. Okay, Xn Wn. And since we can start it from X0 W0 also. Okay, X0 W0, X1 W1, X2 W2 like this. Okay, see then this combination of these inputs it will calculate, then it gives us an output as a plus 1, and just now I told you when it gives us plus 1. So when that result is greater than some threshold value, okay, that threshold value just we have assumed it as now 0 here, right? So threshold value is 0, and it gives us output as a minus 1. Otherwise means if this result is not greater than this threshold value 0, it means that the result is less than 0. At that time this perceptron gives us the output in the form of minus 1, as a minus 1. So two possible output values for this perceptron is plus 1 and minus 1. Okay, so just remember this one. And more exactly and accurately, if we want to talk about the output of this perceptron, the inputs what we are given to our perceptron is x1 to xn, and what output we are getting from this perceptron is o of what? O over these inputs. Okay, output over these inputs x1 to xn. So we can represent it as or we can denote it as o of x1 to xn, and this output is represented, output of this perceptron is represented by perceptron is like this, that is o of x1 to xn. So it is a plus 1 when w0 plus w1x plus w2x2 plus w3x3 and so on up to wnx0 wnxn if it is greater than 0, and this is a threshold. Okay, and here it gives us a minus 1 otherwise means if it is a less than 0. Okay, if this product if this summation is less than 0. Okay, then here see wi, what is that? Real valued constant. It is wi is what? Ww is a real valued constant, or just now I told it as called it as commonly, most commonly as weight. And what this weight actually, what is this weight? This weight is nothing but this weight gives us the amount of contribution of input to the output O. Okay, I hope you understood now. So the contribution of input to the output. So what amount of contribution it is giving you. So for example, in your final year project also we ask, usually the external examiner will ask you what is your contribution in your project. Okay, which module you worked on. Okay, and whether you done with your report and your some documentation works or what. So these are our contributions, right? So similarly here, how much amount of degree this input is giving the contribution to our output O. So that output, that contribution of input will be measured in terms of these rates. Okay, so this is just a general concept idea, just remember in your mind, and note that this quantity whatever I just told you w0, so it is also called as a threshold. W0 is called as a threshold here. W0 is a threshold, that the weighted combination of these inputs w1 x1 up to wn x1 must surpass. It means that so these the remaining terms are there no, in this equation w1 x1 w2 x2 and till wn x1. This summation should be, this value should be keep on increasing, or it should be greater, or it should be exceeding, so that we can get the output value as a 1 for this perceptron. Okay, so when it is, it means that so for particular threshold, these values should be keep on increasing according to this weight, so that we can get the output of this perceptron as a plus 1 only. Okay, so here these values will be these values w1 x1 plus w2 x2, this value should be greater. Okay, so these values will be dependent on each other. Okay, so this value is dependent on this value, that is threshold value, that is w0. So these all things we will see in the next in with one example. Okay, then see, to simplify our notation, whatever just now I had written on the example, one equation there for output of our perceptron, that is O of x1 to xn, plus 1 minus 1 plus 1 when it is plus 1, when it is w0 plus w1, and these all things, whatever equation I had written. So if instead of writing that much lengthy output, instead of writing that much lengthy output, one second. So instead of writing that complete notation, uh, we can make it as a short notation. So for additional constant input x0, we have not considered here, right? So to consider this x0, we have to once again reform our formula in this way. What is that? This one, summation of these products, that is wi into xi, and I value is 0 to m if it is greater than 0. Okay, so like this we have written, and we can represent this equation in a vector form also. Just now in previous slide, whatever I have written here, the same thing I have written in a very small representation or short representation like this. It means that wi and xi should be greater than 0, so that we can get the output as a 1. And this same equation and same notation can be written in the form of vector format also, or vector form. How it is? It is just w vector, or vector w, and this is a x vector. So multiply together, and it should be greater than 0. So this is also called as perceptron function. Okay, so these all are this is a basic one, that is O of x1 to xn, these all things basic. Then we have refined it like this, then again we have refined like this in the form of vector. And for brief, for short, sometimes we can write this perceptron function as O of x vector. O of x vector is equal to sine of w vector into x vector. Okay, see here we have used one new term, that is a sine of w vector into x vector. So this is a final short and sweet representation of our perceptron function. Okay, so just remember this equation. What is a perceptron function? How to represent it? O of x. Okay, it means that output over input. Output. Okay, uh, this session will end in 5 minutes. Once again you rejoin with same link if this session ends now within 5 minutes. Okay, so once this session ends, you rejoin with the same link. See, uh, this representation, what it is giving us, it is a output over the input x. That's all, nothing is there. Don't add these all equations, try to understand these equations. Output of, or output over the input x, and it is a vector x. Okay, because set of inputs are there, right? So it is a vector of x, or vector of inputs. So what it is equal to? It is equal to sine of the multiplication of weights and inputs x. Okay, so weights of sine of weights and inputs. So here now we will see what is this sine. The sine of, suppose if the equation is like this, sine of y, what it means? Sine of y will be, sine of y will be plus 1, and it may be minus 1. So when it will be plus 1, if that y value is greater than 0, and if that y value is less than 0, then it will be minus 1. That's all. Okay, so here in the place of this sine of wx. What you can imagine is, you can imagine it as a plus 1 or you can imagine it as a minus 1. Just now you understand, try to understand the output of x. So output of your perceptron over the inputs x vector will be either positive 1 or plus 1 or minus 1. Now are you understanding? See, so previously I told you the output of perceptron will be either plus 1 or minus 1. Right? The same thing here I am telling you. Sign of w into x is nothing but what it is. This is nothing but it is representing one integer value, that is a plus 1 or minus 1. And when it is plus 1, if the uh, whatever the variable you pass to this function sign, that value is greater than 0, that y is nothing but, this y is nothing but, it is the product of w and x, product of w and x. So w vector into x vector. If its value is greater than 0, the output of your perceptron will be plus 1. If your output is less than 0, sorry, if this product is less than 0, then your output of your perceptron will be minus 1. Okay, so here in this diagram also I have shown you, right? So in this equation also I have shown the equation is reformed like this 2 times or 3 times like this for our short and convenient purpose. Then this main task, I already told you, the main learning the perceptron, learning a perceptron is nothing but choosing the weight values or selecting the weight values here. That's all. So input will be given by somebody, but the main thing is finding or determining the weights for these inputs x1 to x2. So that is the main challenging task in this module. Okay. So choosing these weights and weights values will be W0 to Wn. And in the previous module, I was telling about hypothesis space, correct? See, this hypothesis space uh, is in the first module, hypothesis space was a set of hypothesis small letter h, right? And that hypothesis space, overall hypothesis space was represented as a capital H. Okay, that is set of hypothesis. Now in second module also we considered this concept hypothesis space. Okay, but there also we considered this hypothesis space as a capital H only. But inside this hypothesis space, there were some hypotheses. In the second model, those hypotheses were nothing but they were decision trees. Okay, so in hypothesis space, n number of decision trees were there in previous model. Similarly, here in this module, since we are talking about artificial neural network which is dealing with some weights, the hypothesis space is nothing but it is a space of some weight vectors. Remember this word, weight vectors. It is nothing but a set of weights are there in this hypothesis space. So capital H is full of small letter w's, full of small letter w's. What these w's? Weights. And what type of weights they are? They are